All right, for symbolic arguments, we do have to know several parts of the logic unit. So we do have to remember what is a negation, what is a conjunction, what is a disjunction, also what is a conditional and a biconditional statement. So we are going to have to remember all of those because we never know which ones might pop up. But we're going to be doing an example today where we learn how to translate a symbolic argument and how to complete a truth table. So first thing we have to know is what is a symbolic argument, right? So a symbolic argument is when we combine what we call premises and conclusion. So this is what it's going to look like, right? You're going to have a premise, which doesn't have to look like this, right? It could be, in this case, it's a conditional, but it could have been a disjunction, a conjunction. It could have just been a simple statement. And then you have something called a premise too, which again could be any of the symbols that we've learned. And then you have a line, and on the very bottom, we have three little dots where you write the conclusion. So again, this is just an example. Symbolic arguments can be written in many different formats, but it's always going to consist of premises on the top, a line, and then three little dots and your conclusion. Okay, so that is what a symbolic argument looks like. Now, what we're going to be doing is checking if a symbolic argument is valid or not. In order to do that, we have several steps, right? So we have two steps. First thing you're going to do is you're going to have to translate it from the format that we saw on the last slide to a actual a symbolic or a logical statement, right? So we're going to have to convert it. And the cool thing is that it's always going to look like this. So you're always going to have your premise 1 and your premise 2 joined by a conjunction all the time. So you put premise 1, whatever you have, and premise 2, whatever you have. You put those in brackets, and then you put your conclusion on the other side, and you always join those two with a conditional statement. So just remember this format, it's always going to be the same. So premise 1 and premise 2, inside brackets, conditional, and then conclusion, whatever you have. So this is what you're going to have to do. Translate it from the way it looked into this. Now, once you have this, what you're going to have to do is create a truth table for the statement that you have here. You are going to have to create a truth table. You are going to have to fill it all the way. And then we're going to look at the last column. If the last column ends up being a tautology, and a tautology means that we have all truths, then we could say that the argument is valid. That's all we have to do. So we have to make a truth table. If it's a tautology, then we finish and say, okay, the argument is valid. So we're going to go ahead and try this example. If you notice, I made this one a little more complicated so you feel a little more comfortable if you ever come across this. This one you don't see straightforward the premise 1, the premise 2, and the conclusion. So what we're going to do is I'm going to go ahead and read it and then see if you could break it into 3 pieces. So the statement reads, I can eat a whole pizza, or I can eat an order of tacos. I can eat an order of tacos. Therefore, I can eat a whole pizza. So that looks crazy because it's in paragraph form. But if you notice, there's some little grammatical things in there that help us break this into pieces. So hopefully you agree with what I did here. Every sentence is actually a part of my symbolic argument. So the first sentence, which was I can eat a whole pizza or I can eat an order of tacos, is actually my first premise. I cannot eat an order of tacos, which was the second sentence, was my premise number 2. And then let me just go back real quick. Every time you see the word therefore, that's just shouting out, hey, I'm the conclusion. So therefore translates into the little dots, and then anything after that, which was I can eat a whole pizza, becomes my conclusion. Okay, so we just translated a little paragraph into a symbolic argument that has premise 1, premise 2, and a conclusion. Of course, that's only step 1. Step 2, now we have to translate this into letters. So if we read this through, hopefully you agree with me, is that we have 2 mini statements. We have a statement that says I can eat a whole pizza, which is going to be represented with P. And then I can eat an order of tacos, which is going to be represented with Q. Now, with that being said, let's take this slowly. So let's go through premise number 1. I can eat a whole pizza. That is P. I can eat an order of tacos. That is Q. And they're joined with the word or. You should know that that is a disjunction, right? From now on, or disjunction. All right, let's go to premise 2. I cannot eat an order of tacos. Cannot. that is shouting out, hey, I'm a negation. Eat an order of tacos, that is Q. So I cannot eat an order of tacos, that is not Q. Now let's go to the conclusion. I can eat a whole pizza, that is P. So look at that. We translated from a paragraph to a symbolic argument. Now we translate it into letters, right? So we have P or Q as premise 1. We have not Q as premise 2. And then my conclusion is P. So hopefully you're good up to there. Now they're asking us, hey, is this valid or not? So if you go back to the steps, right? Step 1, we're going to have to translate this symbolic argument into a string, right? And we know how to do that. So this is where we are right now. And then remember the format. In order to translate this, it's always like this. Premise 1 and premise 2 in brackets, and then a conditional statement, the conclusion. Remember that. Remember I told you this is always going to be the setup. So my premise 1 is this part right here. My premise 2 is this right here. And my conclusion is this right here. So this magically becomes this right here. Okay, don't freak out. Look at this. We have premise 1. We put it in parentheses because it has multiple letters in there. So that just helps us keep it organized. And this is always going to be there. Premise 2, which was not Q. I didn't have to put parentheses on that one because we only have one letter. If it would have had several letters in there, I would also put it in parentheses. Conditional statement, that's always going to be there. And then my conclusion. My conclusion was only one letter long, so again, no need for parentheses. All right, so take a deep breath. That's what you do. So you convert a symbolic argument into a logic statement, kind of like a string, right? So that's easy to manage. All right, now, in order to check if this is valid or not, the last thing we have to do is just create a truth table for this. Of course, we could have done it from the beginning because it was in paragraph form, so we had to translate it into sentences. And then those sentences, we had to translate them into letters like we did here. And then those letters, we had to translate them into a string like this. All right, so we made it through the hard part. Now let's just make a truth table. So here we go. For this statement, we only have 2 letters, P and Q. So this should be simple. We only have 4 different rows. We have P, which starts with 2 true, 2 false. And then we have Q that starts with true, false, and then just alternates all the way down. So remember, when we only have 2 letters, we only have a total of 4 rows. That's it. If our statement would have had P, Q, and R, then we would have had 8 different rows, but that's not the case. All right, so let's go ahead and get this started. If you notice, the first thing you should see when we have this type of problem is that there's a negation. So negation Q, let's just get that out of the way. We always get negations out of the way first. So negation Q, I'm going to create a column for it, which is this one. And remember, negation is just the opposite of Q. So I come to the Q column and I just negate everything. So the true becomes false, the false becomes true, the true becomes false, and the false becomes true. So super simple, nothing crazy. All right, we have this done. Now, remember, brackets means we have to do everything inside the bracket first. So I have to join it with this. But the problem is I don't have this done. So this is my next step. We're going to have to create a column for P or Q. So here we go. So we already had this column. Now I'm going to do the column for P or Q, which is here. And again, you do have to know what the symbol means. So remember, this means disjunction. This means or. This is true when we have at least one true. So just remember, disjunction is true when we have at least one true. So we're going to look at the P column, we're going to look at the Q column, and combine them with a disjunction. So here's the P column, here's the Q column. Let's go ahead and fill this up, right? So true or true, true, true or false. Hey, we have a true in there, so true. False or true, we have at least a true in there, so this is true. false or false. There's no true in there, so this is the only one that is false. Okay, so baby steps, we're getting closer and closer to the end. So we have a column for this, we have a column for that. So now we can make a column for that whole thing. Okay, so let's do that. So again, since we already have a column for P or Q, it's right here. And we already have a column for not Q, which is right here. Now I could join them with an and. So that's what I'm going to do. So false and true. Remember, for and, which is a conjunction, they both have to be true. So false and true ends up being false. True and true, very pretty, that one's true. False and true, false, because remember they both have to be true. True and false, that's also false. Okay, take a deep breath, we're almost done. So let me clear this up, make it pretty. We have all of this done. We have a column for that. Now, before I tackle this, let's check. Do we have a column for this already? Yes, we do. We have a column for P from the very beginning. So we are actually ready to tackle the whole thing. Again, because I have a column for each part. So the next thing we do is we do a column, which is our last column for the whole thing. Now, how in the world do I fill this up? Well, let's check it out. Since I have a column for this one, right here, that's what I'm going to be using. And then I have a column for P. That's what I'm going to be using. So again, you don't use the whole truth table. You only do 2 columns at a time. Now, be very careful with this one because they're joined with a conditional. And conditional, the order matters. So it has to be this letter first. If then this letter comes next. Okay, so I'm going to write this slowly. So for this one, for the first row, we're going to take this letter first. So if false, then the p-value is true. So true. Okay, so hopefully you know what's happening, right? I'm taking this truth value first, then this truth value. Okay, so if false, then true. So for this one, you should know that this one is true. Okay, because remember, for conditional, it's always true. The only one that's false is when you have this right here. This is the only one that's going to end up being false. So let me just put this on the side. That's only one that's going to be false. All right, let's try the next one. If true, then true. So if true, then true. Hopefully you agree that is true. Next row, if false, then false. Okay, so if false, then false. Again, look at my note up there. Everything is true. The only one that's false is this one. So this one's also true. All right, very last one. If false, then false. I'm not going to write it because it's the same thing as this one. If false and false, then this one is true. Okay, so again, this relies on your knowledge of conditional. You have to know what a conditional statement is and when is it true, when is it false. All right, so we have successfully finished the whole truth table, but we're not done yet because the question was, is this valid or not? So the last thing we have to do is just stare at this column. What do you notice? They're all true. So since they're all true, this is a tautology and we can conclude that the statement is valid. So that's all you would do. But again, it's impossible to find out if it's invalid or invalid because we had to make this truth table.